In this video, we're going to talk about the Starlogo application stabilizing selection. All right. So stabilizing selection is an evolutionary principle where organisms that display traits at the far end of the spectrum are at a disadvantage, and those organisms that are in the middle are at an advantage. One of the examples they always give of this is robins. Robins typically always lay 4 eggs. Rarely they'll lay more, rarely they'll lay less, but almost always they lay 4. And the reason is fairly simple. If you lay 3 eggs, since there's a high mortality rate in the chicks, it's possible that you could expend all the energy and lose all the chicks. So 4 gives you a greater probability that some of the chicks are going to survive. But if you have more than 4, and they all do survive, then the chances are that none of them will get enough food and they'll starve to death. All right? Or another example of stabilizing selection, giraffes. All right? Now everybody thinks of that as a directional selection because they're getting taller, but if you think about it, since giraffes now all have achieved this height, they got taller so they could reach the food source, but now the negative probability or the negative advantage, implications of being tall, like for example the fact they have to pump all blood all the way up to their brains, the fact they have to bend over to drink water, that has caused giraffes' height to stabilize at what it is today. So in this project we're going to be working with sand lizards. All right, and sand lizards, okay, are an organism that lives on the beach, all right, and they eat sand fleas. They breed up the grass, and they tend to eat vegetable matter when they're young. But when they get older, they have to move out to the beach so they can eat the sand fleas if they're the main part of their diet. And like most organisms, there's a range in size. There are some that have a size of about 1 centimeter, and they range all the way up to 6 centimeters. This is important because they have different various skills and abilities. Okay, the little guys are very able and easy to dodge around the rocks, but they're very slow. They have very small stride. Whereas the large ones are very fast, but they have a hard time hiding. All right. So what you do is you present this to the students, and my suggestion is that you have them use this Google form. Now, if you find the Google form awkward or you just want to skip that, you certainly may. But what I usually do is I ask the kids to read the situation and then explain what they think is going to happen. They could do what I'm going to do right now and just type in gibberish, but you'll know that. But basically, what I would think would happen would be the big sand is going to be caught by the big sand is going to get caught by the seagulls, and the little guys are going to also get caught by the seagulls because they're too slow. And the medium-sized sand fleas are going to survive. Sand lizards, excuse me, are going to survive. So once they answer the question, they say, okay, this is the password that will unlock the game. X, Y, Z. So you go back over here, where it says show submit forever. You type in X, Y, Z. You hit setup. It produces a whole bunch of sand lizards, as you can see. And what you'll notice is there are lizards of varying sizes. Okay, here they're indicated as a dragon beacon. All right. And here are the conch shells. The white represents the conch shells, and these brown guys, these are all from the top. These are seagulls that are hopping around right around on the beach eating lizards. Over here, it's going to tell you, red line indicates the little lizards, orange, the size 2 lizards, black is the size 3 lizards. Those are the ones who are best adapted to hiding the conch shells, 4, 5, and 6 centimeters. So let's see what happens when we do this. All right, one of the things, and it is a bug of the program that you need to be aware of, you want to keep the engine speed at about 5. If it goes much faster, for some reason, it winds up, the seagulls actually have 2 successful predators, and they wind up wiping out everybody. So if you actually watch the seagulls as they run around, they will turn towards anybody that they get within 3 clicks of. All right, so if you take a look and you want to watch out, you will notice that they don't go in a straight line. They have a tendency to head for something. If they get close to it, they will turn towards it and will eat it. The other thing you may also notice if you watch is that if a seagull gets near a lizard, it will try to run for the conch. And you may notice that they'll stay in the conch shell until the seagull wanders off. All right. So one of the things you can see here is that right now, if we take a look at this, the size 1 guys aren't doing very good. They're disappearing pretty quickly. The size purple are also disappearing pretty. Right now, the size 2 guys seem to be doing the best, and the 3 are kind of doing intermediate. So we're just going to let this run for a little while longer, and then we'll just see what winds up happening. I'm going to speed it up a little bit. Hopefully we won't crash the system. All right, what seems to be happening is the size 2 samplings seem to be samplers seem to be doing pretty good. All right, the size of the others, the size 3 seem to be doing the second ones. All right, but you'll notice that we've wiped out all the intermediate size, all the very, very large and very, very small sand lizards, and we're just left with the 3s and the 4s. All right, now actually, if you take a look now, you'll notice that the size 3 samplers is not actually doing so good. It seems to be most of the size 2. So it's an intermediate. It seems that the perfect size here in this run seems to be size 2 samplers. All right, so what happened? All right, so there was a perfect size for the lizards to be. All right, in this case, it seems to be size 2 lizards. So let's actually take a look at it. But now the way you do this is if this said edit mode, you would want to click on this. This is now currently in edit mode. Okay, and I just clicked on play mode. Play mode only shows this. Let's actually take a look at. So this is what it looks like. Let's take a look at the code. I'm going to click on view code. If you get that button, that's what you should do. So the first thing I would do with my class, I just have to play with it and just see what happens. All right. Now, what you do now is we're actually going to look underneath this, and we're going to actually, if you've done some work with Starlogo, there's a lot of terrifying coding here, but actually, basically, there's only 3 basic things. All right, the extensions we're not going to worry about right now. That's a little bit later. The setup, though, tells you what's going to happen. All right, if you take a look at the data boxes, we have to reset all the data boxes. This is the key code right here. You create 10 conch cells, you set the size at 3. 4 birds, you make them seagulls, set the size at 5. And you create 100 ground lizards, and their size is going to be a random number between 0 and 5 plus 1. All right, so that basically gives you random 0, 1, 5. The problem, of course, with that is what that will do with the size is it will mean that some of your sets, sometimes you have a very small number of size 3 or size 2 sand lizards. But that is the way it works in nature. All right? You can only, in this box here is how I get it, so that you can only run the program after you've done the thing. You have to know the password, XYZ, before you get in. The key information, I think, is here with the birds. If you take a look at the birds wander around, they have a random direction, and then what they do is they look for conch shells, and if there's no conch shells, then they go for the closest lizard. Now, what that means is that if there aren't no conch shells in the area, that means that the lizards are visible, and they should be able to get them. So they go, and they can see lizards that are within 4 steps of them. All right? So what they actually do is they face towards them, and then they jump on them. All right? Other than that, they just keep on walking. Okay? On a collision with a ground lizard, okay, if there's a conch shell within 0 steps, in other words, if the ground lizard is in a conch shell, if there are no conch shells within 4 steps, in other words, if the lizard is in a conch shell, they can't eat the conch shell, the lizards. All right? So let's actually take a look and see what the ground lizards do. What the ground lizards do is the ground lizards do something kind of cool. They get older, and then what they do is they breed. All right, so they actually have a procedure for breeding. All right. The other thing is, though, is what they will do is if there's a bird getting close to them, okay, and their size is small enough to fit in the conch shell within 100 steps, they're going to face towards the conch shell and they're going to run towards it. All right, so that's what that does. So that's how that works. So this is actually kind of fun. The kids can play with it. They can look under the hood and neck and see what it does. What I would also suggest, I've created some other possibilities. All right, and all I've done is I've created these little codes here: conch size variability, gull eyesight variability, and conch capacity variability. And those are just different ideas. We could say, okay, so how can we change this project? So one of the things that kids could do is they could say, what if the seagulls, instead of being able to see the nearest guy within 4 steps, what if they could see the nearest ground lizard within 10 steps? How would that affect it? All right? And so the kids can play with some of the coding and run with it and change that. What they could actually do is they could create sliders here that would allow them to improve or make worse the bird's eyesight. So The first part, you actually just do the concept, what is stabilizing selection. And the second part, the students have to actually think about, okay, so how does this environment work? And then the third part of this, where they actually create their own environment, where they try to make the environment better and more realistic. All right? So that's this project for today.